Welcome back to another video. Thank you so much. If you watch any video prior to this one, whether it's this series or another with Linux, with Azure, with AWS, cybersecurity, thank you for any of it. Now, in our last video, we went over securing a cloud solution. That was part two, I believe. We went over that one. And in this one, this is another two-parter. We're actually going to do two-parters for the rest of this portion of the cloud series. We're going to start with, on this one, maintaining a cloud solution. Right now, with maintaining a cloud solution, we're going to be going over like backing up and restoring file configurations, maintaining the OpenStack environment, which looks like a pain to log in every time, and a few other things as well. We're actually going to be creating a flavor in the OpenStack instance, and we're going to be creating images, internal networks, and creating an instance and key pairs in the OpenStack instance as well. So we're going to be doing a ton of fun things. So we can actually go ahead and get started. First with backing up and restoring configuration files. So the directory contains details, right, such as the live inventory, host structure, network information, passwords, and options applied to the configuration files, right, for each service in the OpenStack development. Now, in case of a disruption, I could restore the directory from its backup. Now, to restore it, he had to copy the backup of the directory to the cloud environment. So that's why I'm going to do this now, so we can understand how to do this. Right. So let's open up Putty. Now for disaster recovery, it's a good practice typically to regularly back up the database, configuration files, and network information in OpenStack service details of the environment. So for an OpenStack Ansible cloud, right, you back up the etc OpenStack deploy directory, and it's recommended that the backups are made to a remote location, right? So now that we've logged in to deploy, we can list the contents now of the directory that's here. Okay, not bad. A lot of different, we'll just list the files that are needed to back up the configuration files for the OpenStack instance. Now I'm going to create a backup directory here. Okay, perfect. That's good. So far, so good. Now I'm going to create a backup of the files and folders in that directory with this here. That's interesting. Okay. All right. Nonetheless, now the tar command was used. You can see here and here. Right. So the tar command was used to create a manual backup for the directory. Now, a script file can be created, which can then be used to automate the backup process. For example, a backup can be scheduled to run on a daily basis at a certain time. In this example, if the command is rerun, it will overwrite the previous backup that was made. Now, the script file that can be used for the backup can be created so that a new backup is created on a daily basis, thus creating a retention period for specific dates. And this is useful if an incident has occurred on a specific date, of course. Now I'm going to verify our menu backup here with another command similar to what we used 2 commands ago. Total 0. Okay. Now I'm going to list the contents of the backup file. So let's use tar again. This time I'm going to use TF. Let's take a look here. It's not recoverable. Huh. Okay, now the backup was done to a local directory on the server for the purpose of this lab. So it's usually best practice to have a remote destination for backups I mentioned earlier, for instance, a shared network location. This will ensure that if the server fails, that the backups files will still be available. Not sure what's going on here with this particular. Um, Let me confirm what I have here. This is usually, at least with me, I'm not sure about anyone else, but usually a user error if I'm receiving something I don't want to see. Hmm. Okay. I'll still move forward. Now, to restore the OpenStack environment from a backup, backups are used to restore data if an unforeseen incident has occurred in the environment, right? It's for just acute purposes. So the configuration settings for the OpenStack environment are stored in the directory. And this directory was actually backed up just a few moments ago when I just did. So our session is still active, so I can again take a look. Okay, still zero. Now to view them, I'm going to um, take a look at this again. Hopefully it'll do what it's supposed to do this time. All right, so the content of the backup file should be displayed instead of saying an error is not recoverable. Now, the contents of the directory that was backed up should be seen, and I'm actually going to fix this. But it's always good practice to review the content of the backup file before restoring it to verify any content. Now, to restore the content of the backup file to the original location, you could do a command such as this. Okay, again. Um, let's just see if the backup. I don't think it was successful from the results that I'm seeing. So let's see. Hmm. So there is something there. For some reason, it's not responding when I'm calling out to it. Right. Uh, so there's something there. Again, I'm not sure what's going on when I'm trying to recall it. But nonetheless, we can move forward. Now, we can take a look at maintaining the OpenStack environment. Now, the maintenance is needed to ensure that the environment runs smoothly and prevents unexpected downtime. Thus, it is necessary to ensure there is a maintenance strategy in place, and the strategy can be automatic or manual provision strategy. Now, I'm going to implement manual maintenance strategies, and keep in mind that these specific tasks can be automated in a production environment to ensure consistency of the task, right? That I'm going to perform. Now, another benefit of automating these specific tasks is that it will run on a schedule and prevent human error. Right. So first, what I'm going to do is create a partition for the instance on OpenStack. Right. So what I'm going to do is I'm going to close this session. I'm going to reopen a new one. I'm going to create a partition for the instance, right? And the partition that will be created will be used to store the data for the instance on the storage server. And the storage is a critical resource, of course, in cloud infrastructure, nothing else. It needs to be maintained to ensure that the cloud infrastructure functions correctly. So instead of deploy, this time I'm going to do open storage here. And instead of the root, I'm going to do administrator. All right, perfect. Now that we're in, we're going to check the disk here. partition to just not start our physical sector boundary. Now, the new disk with the 160 GIB is space is present. A new partition needs to be added to this disk. So I'm going to tell it to do exactly that. Did I? Yes. Okay, I did it. Now for the new partition, I want to do this one here, right? And then for primary, do that one. And for the partition number, I'm gonna hit enter. I see it here. Then for the first sector, oh, so I got the partition number. The default is one. I got the first sector. Now for the last sector, got that here. Perfect. And then 4319. Now I'm going to take a look at the newly created partition. Here. There we go. Perfect. And we see it's DVSDB1, right? And I'm going to save and quit with a W, right? Perfect. So we're good there. So now I'm going to confirm that the partition is added successfully here. Perfect. Yep. Looks like it's good to go. So now I'm going to create the physical value for the partition. Let's see here. There it is, successfully created, just what we like to see. So now I'm going to check the physical value that it was successfully created. All right, yep, looks so far so good. So now I'm going to create the value group here. Perfect. So now I'm going to confirm that the value group is also successfully created. So let's do that there. And then I'm going to restart the system for the changes to actually take effect. That is not how you spell reboot. All right, that's fine. Perfectly fine. That's expected also. So let's actually restart the session to restart the secure shell connection. All right, should actually log in. There it is. Okay. All right, perfect. I'm actually going to minimize this. So what I'm going to do now is create some flavors in an OpenStack instance. So I'm going to create a flavor that defines the computing memory and storage capacity for the instances, right? Or a virtual service that's going to be provisioned. So now that I have Firefox open, let's actually head over to the site. Okay, perfect. And of course, we're going to log in as the admin as usual, right? And I'm actually going to open up a new, you guys know the drill as far as me getting the password. So I'll place you on the other side of that once I'm logged in. All right, now that I'm all logged in, I'm going to take a look at the compute portion of this, right? It's going to open up further options for us. So let's take a look at flavors naturally. I'm going to create a flavor, right? And we're going to create a flavor here because there's none to take a look at. Now, it has the flavor information, right? And flavor, what it defines is the size of the RAM, the disk, and the number of cores and other resources that can be selected when users deploy instances. So I'm going to test flavor, right? Perfect. And the ID, auto is fine. A UUID will be automatically generated for the flavor, which is okay. Now I'm going to add the number of virtual CPUs required, which will be just one, right? And then I'm going to, for the RAM, I'm going to specify the RAM to be 512 as far as megabytes, which is pretty okay. Now for the root disk, the amount of disk space in gigabytes to use for the root partition, I'll do it about 10, should suffice. Now, ephemeral disk, right? They offer machine local disk storage linked to the lifecycle of a virtual machine instance. When a VM is terminated, all data on the ephemeral disk is lost. And in this case, it would be unspecified and the value is zero by default, which is, you see the zero here. Now, the swap disk, it won't be used in this lab, but in Linux is used to create the virtual memory for a system. So when a system runs out of physical memory, the swap disk is used to supplement that. And I'm going to leave the RxTX factor unchanged at 1. And now I can create my flavor, right? So now I'm just going to create an image in an OpenStack instance also. So an image needs to be created before an instance can be created in an OpenStack environment. And the instance is created using the image that's uploaded. So I'm going to create an Ubuntu image, which would then be used for an instance creation. So it's actually, which one? I'll close this one out. Don't need that one anymore. So let's minimize this. That's the password there. Let's open up a new one here. Deploy. Right. Okay, perfect. So now I'm going to connect to this node for here by establishing a secure shell connection. Okay, so far so good. All right, so now I'm going to determine the name of the container. Okay, perfect. So now I can see it, C2E 40761. Now I'm going to access the utility container itself. So let's see. There we go. Oh, my bad. There we go. Wait a minute. Okay, I see here. There we go. I always fix things. So now we can take a look here. Okay, perfect. And we're in. And now I'm going to download the image. Which looks good. It's going to be doing this. Perfect. Looks like it's going to take longer than I thought. So the Ubuntu Zenio image was successfully downloaded as indicated here. So now what I'm going to do, since I'm still inside the utility container, is I'm going to create an image with the disk format in a container format. So let's actually do that here. And I'm actually not going to put you guys through this kind of long, so I'll place you on the other side of this as well. All right, here we go. I waited on you guys to press enter. Right. So the image should be named test image and it should be created. Yep, there it is. The name. All right, perfect. So now the newly created image needs to be verified, of course. So I'm going to do this here. Perfect, active. So we're good to go. All right, so now I'm going to create an internal network in an OpenStack instance. So I'm going to create this, and it's going to be used to connect specific instances to ensure communication between instances. And it's going to be compared to a switch. Um, in a physical network infrastructure and instances in OpenStack are usually virtual computing nodes that are created. So now what we're going to do, oh, good thing it hasn't like logged this out or anything. So I'm going to click project here and let's see, network. All right. And then let's click on networks again. All right. And I'm going to create a network. All right. And we're going to name it int net one. I'm going to hit next here. Subnet name. All right, network address is going to be here. All right, we can actually do next here. Now, for our subnet details, we're going to actually, let's see, I'm going to go to create the internal network. All right, so now as we can see, it's been successfully created. So now I'm going to create a security group in the instance, right? So a security group, as I mentioned in a prior video, it's used to open specific ports in the network to facilitate communication. For instance, opening the correct port for a secure shell connection. So I'm going to click project here again. Okay. All right. And let's see. Network is good. All right, let's take a look at our security groups. Now I'm going to create a new one like I did before. And this time it's going to be new name. All right, and create security group. And you can also manage rules. You can see over here, but we can see that it was successfully created. Now I'm going to manage the rules as I mentioned. All right. Now it's already two rules here, but I mean, we're still going to add a new one. Those are really the default rules. So I'm just going to have the rule as SSH. Okay, perfect. Now I'm just going to click add. I'm not really going to do too much of anything, but it has been successfully added, as we can see here for port 22, right? And now I'm going to create key pairs for an OpenStack for this OpenStack instance for secure shell connections. So I'm going to create key pairs right, that are utilized to securely connect to virtual machines using that connection. And instead of using new username and passwords, public and private keys are going to be used for authentication. So let's actually take a look here. Key pairs. And of course, going to create one naturally. We want to do a test key pair, right? That created. Should show it in a moment. That's fine. You can do that. Now, the private key that can be used for the secure connections are displayed, as we can see here. I'm going to close this out. Now I'm going to create an instance for the OpenStack environment. Now, virtual machines are called instances, right? And what I'm going to do is create an instance in the OpenStack environment. Now, the previously created flavor that I had, the key pairs that I have, the security group, the internal network, and the image, if you remember from PuTTY, previously created, will be used to create the instance. So I'm actually going to take a look at this. It says here, and I'm actually going to, let's see, there it is. I don't know why overlooked it. So it's going to be a test instance, just like with everything else. All right, perfect. And get that next. All right, and now I'm going to choose yes, this is fine. We're deleting value, right? And then let's see. Oh, I see it here. Okay. Did it work? Okay, I see it here. Yeah, the test image. All right, so we're good here. All right, perfect. So now, as we can see, the test image, I was boggled why it disappeared on me for a second, but now it's seen in the allocated section. So actually, I can move on to the flavor tab. Now, similarly, the test flavor can be seen in the flavor tab, which needs to be allocated to the instance. It's in the available section, so I'm just going to hit here. Then it's going to be allocated as we saw with the tested image. Now, in the flavor tab, the test flavor can be seen. So I'm going to, now that it's in the allocated tab, I'm going to go on to the networks here. Now, this one was already created. It's already allocated to the instance. So I'm going to move on to the network ports. And no changes are really needed here. So I'm going to go ahead to the security groups. And the test AG can be seen as available. So I'm going to put it in the allocated here. As you can see here, I'm actually going to move this. So the test AG is now allocated, right? So now we can move on to the key pair. And we can see the test KP is already allocated here. So I'm actually going to launch the instance. The new instance should be that was created should be displayed in a second. There it is. Perfect. That is beautiful. Now the test instance is running, and the IP address of the instance can be used to connect using the secure shell and the key that was generated just a moment ago. And now I can move to some soft rebooting for this instance. So I'm going to soft reboot the instance and do a soft reboot. And it's typically used if an instance needs to be restarted, but the processes that are currently running will shut down correctly in the process. It's simple to pretty much restarting a server using the correct method. All right, so let's take a look here. Oh, already here. So check this box. Why is it? Let me actually do this here. Good. All right, perfect. So it's actually um, back. Soft reboot. There it is. As you can see here, now it's saying, hey, you selected this, blah, 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 blah. This and that. All right. And by selecting this, the OS will be notified as it just did to restart all of the services. They're going to shut down normally before the system is restarted. And usually this task is used if the system changes have been made to the OS and need to be restarted. And as you can see, it's not currently running, but the reboot has started. All right. So just like we did a soft reboot, we can also do some hard rebooting. Now, if we hard reboot, right, and it's the same as when the power of a physical machine is switched off manually. So this is used if the instance has become like unresponsive. There's no other way to gain access to it, right? That is the same, literally the exact same process. You just go here, and if it wasn't rebooting already, it would have hard reboot. Not sure if you've seen it before I did the soft one, but nonetheless, it would pretty much have the same notification, and then it would be successfully hard rebooted. Now we can also, I'm not going to get into that now since we already have one running, but we can also shut off an OpenStack instance. So the instance that was that I created here, the test instance, can be shut down, and it might need to be shut down for maintenance purposes, for example, like adding resources or something like that. So we can actually, if I click this checkbox here, I can actually delete the instance, right? or shut. I'm not going to delete it actually. I can shut off the instance instead, right? And it'll also give me confirmation that I'll be shutting it off here in a dialog box. Now, after it's just shut down, it typically becomes inaccessible until it's started again, right? So, but there's different options available, right? That you'll see in red, that you see is soft reboot and things of that nature, hard reboots. Now we can actually, now what I can do is actually create a snapshot of an OpenStack instance as well, right, of this one. Now to create one is a way to create an image of the instance. So if something occurs in the infrastructure, the snapshot can be used to restore the instance to a specific point in time. Think of it as kind of like time machine for Apple if you use the Apple platform or device. Um, so we can actually, let's see. Um, okay, just, okay, there it is. So as you can see here, create snapshot, right? So I can do that there and snapshot. There we go. So we can create it. And it has been successfully created as we can see here. Oh, here, it wants to work correctly. Now it's saved in the images tab, and the snapshot can now be used to create a new instance or be used as a restore point for an instance that may have gone corrupt, unfortunately. And nonetheless, we bring us to the end of part one for maintaining a cloud solution. Just for a brief recap, we went over backing up and restoring configuration files. We also went over maintaining an OpenStack environment by creating a flavor, image, internal network, security group, key pairs, an instance, a soft reboot, hard reboot, shutting off, and creating a snapshot for the instance as well. This was a lot of fun. I cannot wait to get to part two for maintaining it. It's actually going to be the longest video that I have left. I cannot wait to see you there. In the meantime, stay curious, stay secure.